able to destroy a cell that has that antigen in it by using perforin and granzyme to stimulate apoptosis. So, macrophage processes the antigen, secretes interleukin 1. Helper T cell comes over, find the right one, the right helper T cell that recognizes the antigen determinant. The associative recognition, it becomes active or activated, and it releases interleukin 2. Okay. And you'll notice we have a bracket there for this A and B. And the reason that bracket there is that's trying to show you that this is the same exact steps that we were talking about back in humoral, starting on page 116, with Roman numeral 5A. That A on 116 is the same as this A here, only we just didn't add all the detail into it. The B up there is the same as the B on page 117 up until you get to the part where it says attracts B cells, because now we're interested in the cytotoxic T cells.
What was the B cells? 117?
Yeah. Okay. So what we're interested in now, instead of B cells, are the cytotoxic T cells. So when we find the right cytotoxic T cell, it recognizes the antigen determinant, it gets active, it goes through clonal expansion, producing a whole bunch of cells that recognize that antigen, and they're going to secrete a group of lymphokines. And those lymphokines are going to include such things as chemotactic factor. Chemotactic factor is going to attract over more macrophages to the area. They release macrophage inhibiting factor, which will keep those macrophages from leaving the area once they're there. Macrophage activating factor, which is essentially going to make the macrophage a better phagocyte. It's going to increase their phagocytotic capacities. And a lymphokine known as transfer factor. Transfer factor can train naive cytotoxic T cells directly, and what that means is when this initial cell that recognizes the antigen, that actually sees the antigen, goes through clonal expansion, it produces all these clones. None of those clones have actually physically seen the antigen. So the original cell is going to train it, meaning give up some knowledge to it based through this chemical stimulation, so that they are fully capable of reacting against the antigen. Now remember that the cytotoxic T cells use perforin and granzyme to destroy the cell that's got the antigen. So why do you figure they spend not all their time, but spend some time secreting all these chemicals to bring over macrophages? What do you figure that's the purpose for? Anybody? What's perforin granzyme do?
Pokes it. It pokes it and then it more memory for more memory cells.
Causes apoptosis, right? So what do you think this is all about? Macrophages are going to be attracted over there so that they can clean up all this mess that these cytotoxic T cells are about to make. They're about to make a huge mess when they start killing off these cells. Well, you're going to need a lot of phagocytosis going on over here. So it attracts over more macrophages, gets them to be better at it, namely that they're more likely to engage in oxygen burst so they can really take out a whole lot of stuff all at once. But these cytotoxic T cells are about to create a big old mess. Okay. So remember too that when the cytotoxic T cells are responding to this interleukin 2, suppressor T cells were also responding to that, which means that they're going to then eventually get enough suppressor factor out there that they can stop the release of the interleukin 2 from the helper T cell, and that will stop the proliferation of the cytotoxic T cells. Okay. And that's no different, that bracketed D is no different from the D that's on page 118, with the exception that we're dealing with stopping the cytotoxic T cells, not the B cells. And then whatever cytotoxic T cells are left over are going to become the memory T cells. So to try to tie all this together for you, whatever kind of antigen we've got, remember that the first thing that we're going to try to do is just to use our first lines of defense and keep them out. If that fails on us, then both our second lines and our third line is the lymphocytes basically, they're going to engage almost simultaneously. And it's going to start with the macrophage processing the antigen and activating the helper T cell. And once that helper T cell gets active, it releases the interleukin 2, right? And both the B cells and the cytotoxic T cells, as well as the suppressor T cells,